Hey, we're going to take a look at 3 problems from the 2017 Math Counts team round. Now, all 3 of these problems are looking at geometry, and some of them are pretty cool. So we're going to be looking at problems 2, 5, and also 8. So here we go. So the first step in getting any problem right is reading the problem and making sure we understand what it's asking. So I'm going to take a look at that right now. So a circle is inscribed in a right isosceles triangle. So that means a right isosceles triangle means that we have a right angle there, and due to the background knowledge that we know that a right isosceles triangle, also known as a 45 right triangle, has a special relationship amongst its sides. So obviously an isosceles triangle has legs that are the same length, but that also means the hypotenuse is that leg length times the square root of 2. So we need to come into this problem knowing that up front. Obviously we can use the Pythagorean theorem to figure out that this whole length here is 8 times the square root of 2, but it's better if you just know it off the top of your head. So then the question is asking how many square inches are in the area of the shaded portion. Express your answer as a decimal rounded to the nearest hundredth. So we need to have 2 decimal places. Well, it's pretty easy to see that we have a triangle, and we have the area of the triangle, and then we're going to subtract out the area of this circle here. And so let's do the easy thing that we know. We know the area of a triangle is base times height divided by 2. And so we have 8 times 8, which is 64, divided by 2. So we know the area of the triangle is 32 units. And now the tough part, we need to figure out the radius and the area of the circle. So I'm going to go ahead and erase this. Oh, no, that's not what I meant to do. So now I'm going to go ahead and erase this just to make it a little bit easier for me to draw. So at this point I'm really tempted to drop an altitude here, and so that is going to give me a right angle. This is still 45 degrees, so I have another isosceles right triangle, but I know that this whole distance from here to here is going to be half the 8 root 2, so I know this distance is 4 times the square root of 2. Alright, great. So I know that this distance here is also going to be 4 times the square root of 2. Now I'm going to throw in a couple extra pieces here. From the center, I'm going to draw a radius that intersects the tangent point. And by doing so, I know I'm creating a square because, because I am. So we know that this is radius, I know that this is radius, and so that means this distance from here to here is also the radius from here to here, right? And so now I have this kind of cool square, which means that the distance from here to here is going to be 8 minus this piece of the radius that I'm taking out. And so that's 8 minus r. Now the cool thing about that is that means, I'm going to look at my notes really quick to make sure that I don't know where I put my notes. Oh, there are my notes. Okay, so that means that we know that this side length from here to here is 4 times the square root of 2. But we also know that's equal to 8 minus the radius. Oh, well, this is just a problem I can train, track, and solve, right? So I'm going to pull up a calculator because it says that it wants its answer rounded to the nearest hundredth. And calculators are really good for giving me decimal equivalents, right? And so first thing I'm going to do is I'm going to find the square root of 2, and I'm going to multiply that by 4. And so I know that this is 5.65685.4. Now here's something that I know is going to come up. I know that I'm going to have to find the area of the circle. And the area of a circle is going to be the radius squared times pi. Well, if I'm squaring the radius and then multiplying it by pi, and I need an answer to the nearest hundredth, that means I need to keep a lot of decimal places, or else my rounding is going to be off. And even if I'm off by 1/100th, that's going to make a difference in whether I get this right or not. So I need to keep a lot of decimals. So I'm going to keep as many as I can. So then now I know that I'm going to say that this is equal to 8 minus r. All right. So then I'm going to subtract 8 from my decimal. And so, well, that means that negative r is equal to this number here. Well, then just multiply both by -1. So I know that my radius is equal to 2.343146. All right, good stuff. Well, so now what am I going to do? I need to square it and then multiply it by pi. So I'm going to go ahead and I'm going to square this number. And it doesn't matter if it's negative or positive. If I square it, it's going to become positive because negative times negative is positive. So that means my radius squared is 5.490332. Now I don't want to write that down. I really just want to keep it in the calculator. I'm going to multiply that by pi. And so I know I need to round to the nearest hundredth, so 3.14 is not going to be enough decimal places here. I'm going to have to multiply that by 14159. Now, I know I'm going a little overkill on the decimal places. A pi button on your calculator is even better because I don't want to round until at the very end. And that's the trick on this. Don't round to the very end. And so when I get that, so I get the area of the circle as being 17.248372.